Moving on to section 4. So here we're going to talk about chemical and physical changes and what are chemical and physical properties. So again, you've probably talked about these before. So physical changes are where your particles, so that would be your atoms or your molecules, because again, we're talking about things on a molecular level because this is chemistry. Atoms or molecular molecules. They do not change their identity. And kind of a shortcut here is you can ask yourself, did I make something new? If it's a physical change, no. So we can say that nothing new is made. So did I make something new? We can write that over here. Did I make something new? Physical change, no. All right, so examples here. Physical changes are phase changes. So like when water evaporates. So water evaporates, it goes from liquid to gas, but it's still water. Same thing like when ice melts. It goes from solid to liquid, but it's still water. When you put salt in water and it dissolves, it's still salt. How about when I don't want to give my kids a big sugar rush, and so I give them apple juice, but I only put like maybe half of the container of apple juice, and then I dilute it down with water. So diluting, it's still apple juice. It's just diluted. How about when I'm prepping something? So I really like to eat broccoli. I know, weird, but whatever. So broccoli comes in a big bunch. Well, I don't eat it in a bunch. I cut it up. So if you're gonna cut or if you're gonna crush something, so putting something in a food processor, again, we're just changing the shapes of the pieces. Physical changes, not making anything new. And a chemical change. So here, did I make anything new? Yes. So here you have your atoms or your molecules. Are rearranged in a new way. So here you do make a new substance, or maybe more than one. It kind of depends. All right, so chemical changes. Here we're talking about like food prep. Here, when you cook something. So if I crack an egg, guess what? It's still an egg. But when I actually fry it, so when I'm frying an egg, it no longer has that same yolk, albumin thing. So like when you bake a cake, it's no longer this mixture. It's something different. All right. Who likes to burn things? So if you burn something, so like if you burn paper, smoke a cigarette, chemical changes. Silver, what happens to silver if you leave it out in the air? That's correct. It's going to tarnish. Silver tarnishes. Or if you do something where there is any sort of chemical reaction. We'll be doing some of those. You'll be doing them in lab. Okay, so those are changes. So let's talk about properties. So a physical property is going to be what a substance displays without changing identity. So we're not, these are things that have to do with the substance that are not going to actually change it. So color, smell, density, melting point or boiling point, and how something tastes. You can observe all of those without changing substances. Now let's talk about a chemical property. Chemical properties refer to the ability of a substance to form new substances. So how is it going to react with other elements, molecules, compounds? So steel can rust. Copper, what happens if the copper, you leave it out after a long period of time? I hope you said it turns green. That is called a patina. So copper, thing like shiny new penny, although they're not made of copper anymore. But if you find an old penny and you find it's got a greenish blue substance. Fun fact, the Statue of Liberty is made of copper. Guess what color it is now? Green. It's covered in patina. All right, that's correct. Now, how about bleaching? So like if you bleach hair, hair can be bleached. Clothing can be bleached. That's gonna definitely change it into something new. See if you can come up with some other examples.